Okay, good afternoon. So, in the previous session, we discussed limits and existency of limit. So, that is a very important concept we discussed in the previous session. So, if anybody are not watched, let's watch that one. Limits and existency of limits. That continuation is differentiation or else derivatives. Now, I'm going to discuss the topic about derivatives. This is just 1 hour topic. So, in first PUC point of view, very basic level derivatives concept is there. If you understand this basic level, it will be very helpful and easy for your second academic year also. So now in this derivatives chapter, very basically we are going to know about the formulas. If you know the formulas, then you can able to understand the application of the question. Then how can you attempt? You can able to understand easily. Let us start with formulas. The formulas. Formula. So the very first formula, d by dx of x to the power of n is equals to n into x power n minus 1. d by dx of e power x is equals to e power x. d by dx of a power x is equals to log a base e. d by dx of constant, only constant means 0, where k is constant. Then d by dx of constant into x means constant, you can able to take it outside, and d by dx of x, that is equals to 1, means d by dx of constant into x is equals to constant, where k is constant. Of course, d by dx of x is equals to 1. d by dx of x square is equals to 2x. d by dx of root x is equals to 1 by 2 root x, and d by dx of 1 by x can be written as minus 1 by x square. This is the first layer formulas. Then coming to next, you are going to know d by dx of sin x. The formula is cos x. d by dx of cos x is equals to minus sin x. d by dx of tan x is secant square x. d by dx of cot x is minus cosecant square x. d by dx of cosecant x is equals to minus cosecant x into cot x. d by dx of secant x is equals to secant x into tan x. These are the next layer formulas. Then you have to know 4 more formulas. This is a different model. d by dx of u plus v. Sum of two functions are there means you can able to write into sum of two individual functions. Derivative of individual functions. d by dx of u plus v equal to d by dx of u plus d by dx of v. And if it is minus, then minus will get it. d by dx of u minus v is equals to du by dx minus dv by dx. Similarly, if sum of or difference of three functions are there means we are going to apply 3d by dx. Isn't it? Next, very important formula, d by dx of uv is equals to u dv by dx plus v du by dx. What is the formula? d by dx of u is equals to u, as it is write down, into derivative of the second function plus second function into derivative of the first function. Then coming to next, d by dx of u by v. d by dx of u by v. So whenever u by v combination is there, v into derivative of u minus u into derivative of v to the whole by v square. d by dx of u by v equal to v into derivative of numerator minus numerator into derivative of denominator whole by v square. Be careful, multiplication means addition will get, Division means subtraction you will be getting. So this is the very basic concept. You have to know these formulas. So you can able to call this is d by dx or derivative. Both are same. Derivative of x power n into x power n minus 1. Derivative of e power x, e power x. Derivative of a power x into log a by c. Sorry. Derivative of a power x into log a by c. Before that a power x is there. Derivative of constant is 0 where k is constant. Derivative of kx means k outside. D by dx of x according to this one. So k into 1 is equals to k. And d by dx of x square 2x. D by dx of root x 1 by 2 root x. D by dx of 1 by x minus 1 by x square. And one more formula, d by dx of log x. D by dx of log x can add is equals to 1 by x. You can add that formula also. And the derivative of sin x is cos x, derivative of cos x minus sin x, tan x derivative is secant square x, and cot x derivative minus cosecant square x, cosecant x derivative minus cosecant x cot x, and secant x derivative is secant x into tan x. And d by dx of u plus v and u minus v, it is nothing but u by dx plus or minus dv by dx, and d by dx of uv is equals to u derivative of v plus v derivative of u. D by dx of u by v is equals to v derivative of u minus u derivative of v by v square. So in these three formulas related, principal forms are very important. So first principal forms. In that three, this is one of the expected question in 2026 for 3 marks. I will discuss all the three. So we need to check it. Before that, I need to explain this concept. Once you look at and copy it, copy the formulas. Yeah. Now I want to explain once this thing. Look at carefully. So what is this application? D by dx of x to the power of n is equals to, the formula is what? N into x to the power of n minus 1. So d by dx of x to the power of n, it is nothing but x is the function, n is nothing but constant. So whenever function power constant derivative you are going to write, the formula is the constant into function power constant minus 1. So whenever we are talking about this one, just you need to imagine d by dx of the formation is x to the power of some 5, for example. See, x is a function, 5 is just a number, constant. Whether that is a positive constant or else negative constant, not a problem. Isn't it? Then whenever x to the power of 5 is there, according to the formula, 5 into, convert the formula, n into means 5 into x power, okay, n minus 1. 5 minus 1, how much? 4. So 5x power 4 is your answer. Isn't it? For example, you want d by dx of x power 10. D by dx of x power 10 you want means what is the formula? 10 into, can you say along with me? X power, what's that? N minus 1 means 10 minus 1. 10 minus 1 how much? 9. This is nothing but 10x to the power of 9. Understanding? Can I give one more example? D by dx of x to the power of 100. What to do? X power 100 means function power constant, right? 100 into x to the power of 100 minus 1. How much? 99. That's all. So can you able to do in mind this one? D by dx of x power 50. 50 you want. X power 50 derivative. Can you say? 50 into x power 50 minus 1. How much? 49. So 50 x power 49. Can you able to call one more? D by dx of x power 30. 30. So what can I write? 30 into x power 29. Understanding? That's the thing. So once if you know this formula, all these formulas are very easy. Look at, for example, coming to this question. D by dx of x equal to 1. How? Means it is of the form d by dx of x. X is nothing but x power 1. According to this formula, what happened? Function power constant, right? 1 into x power 1 minus 1. N minus 1, 1 minus 1, 1 into x power 0. X power 0 equal to 1, 1 into 1, 1. That's all. That's what you are getting the result as well. Coming to next second formula, check it. D by dx of x square. What is the derivative of x square? According to this formula, 2 into x power 2 minus 1. 2 into x to the power of 1. That is nothing but 2x. That's all. Let us move to next. D by dx of root x. So d by dx of root x can be written as x to the power of 1 by 2. You can fraction also, you can take L value, but this is constant, sorry, function power constant or not, you need to cross check. Yes, this is the function power constant. X is the function, 1 by 2 is constant. X for 1 by 2 can be written as, what is the formula? N into 1 by 2 into x power 1 by 2 minus 1. So 1 by 2 into x to the power of 1 by 2 minus 1 is nothing but minus 1 by 2, can be written as 1 by 2 into x power minus 1 by 2 can be written as 1 by x power half. X power half is nothing but root x. It is nothing but 1 by 2 root x. Exactly that formula only, right? So root x derivative is 1 by 2 root x based on this formula only. This is the origin formula for all the formulas. Look at d by dx of 1 by x. That is also same format. D by dx of 1 by x. What we can able to write? 1 by x can be written as x power minus 1. 1 by x can be written as x power minus 1. Now this formula minus 1 into x power minus 1 minus 1. It is nothing but minus x to the power of minus 2 and hence minus 1 by x square. That's all the formula. 1 by x derivative is minus 1 by x square. So all these formulas are depends on the same thing only. Even including this formula also. Constant. Constant means you can able to take k outside. So d by dx of 1. 1 can be written as what? K into d by dx of x power 0. K into x power 0 can be written as 0 into x power 0 minus 1. 0 into any quantity 0, that's what the quantity will become 0. So including all the formulas, so except log x, remaining all the applications depends on the original formula is x power n only. But we are preparing like individual formulas. Why? Because always we can't apply this formula. That's what we are going to remember like a formula and we are applying whenever it is required. So other than this, whenever we are going to get the situation, we are going to solve the sum according by using the formula. These two are separate formulas. E power x derivative is e power x. Of course, if you take in place of a, if you substitute e, you are getting this formula only. In place of a, if you take e power x into log e base e, log e base e is 1. So e power x into 1 is nothing but e power x. Isn't it? This is what? Constant power function. This is function power constant. This is constant power function. Clear? So this is what? E is the fixed constant power function. This is not fixed constant. A is compulsory, which is greater than 0. A greater than 0, any value can consider. Isn't it? This is fixed constant. This is not fixed constant. For example, d by dx of 2 power x you want. D by dx of 2 power x. A is equals to 2 you consider. What is the formula according to this? 2 power x into log 2 base c. That's all. 2 power x into log 2 base c. Can you able to tell the formula for d by dx of 3 power x? What is the formula? 3 power x into log 3 base c. That's all. D by dx of 5 power x. 5 power x into log 5 base c. But you should not tell d by dx of 5 power x is x into 5 power 5 minus 1. That is wrong. Why? Because this is function power constant. This is constant power function. So whenever constant power function is there, this formula you are going to apply. Whenever function power constant is there, this formula you are going to apply. Clear? The difference between x power 5 and 5 power x, I will explain once again. Look at once. X power 5 and 5 power x. Difference between d by dx of x power 5. D by dx of 5 power x. 5 power x means constant power function. This format. So what you are going to write? 5 power x into log 5 base c. That's all. So function power constant x power 5. This format 5 into x power 5 minus 1 4. That's all. Hope you understood the difference. So these are the formulas which are basic formulas and which are very easiest application formulas. And coming to next, all these formulas also very important. This formulas also having proofs. That proof only important for you, your final exam 3 marks question. So now I want to discuss these proofs by using first principle. Okay, so look at carefully. So if you want to do first principle method, you have to know one formula. That formula I will discuss. Look at carefully. So f dash of x is equals to the formula. F dash of x is equals to limit h tends to 0. What is this? First principle formula. First principle. What is the formula? F dash of x is equals to limit h tends to 0. F of x plus h minus f of x whole by h. Clear? F dash of x is equals to limit h tends to 0. F of x plus h minus f of x whole by h is the formula. So can you able to tell? So whenever they are going to give f of x, you are going to apply the derivative. The derivative is format is f dash of x. F of x derivative is f dash of x. That is equals to formula limit h tends to 0. Can you repeat along with me? F dash of x is equals to limit h tends to 0. F of x plus h minus f of x whole by h. So look at carefully and copy down. Now the question will ask like this. Derive f of x is equals to sin x. Find the derivative of f of x is equals to sin x by using first principle. This is your 3 marks question. Clear? By using first principle, this is your 3 marks question. Okay, so now what to do? So let us write down what is f of x. F of x equal to how much given? Sin x. What is your formula actually? We know that f dash of x is equals to limit h tends to 0, f of x plus h minus f of x whole by h. This is the formula, right? Just now I told. So in this formula, f of x is there here. Now you are going to prepare x plus h, f of x plus h. F of x plus h means very easy. Just you need to replace in place of x, x plus h. Did you clear? In place of x, you are going to replace x plus h. That's all. So wherever x is there, just replace x plus h. Now sin x is there, you can able to write sin of x plus h. Understanding? For example, your question is tan x is there, f of x. So you are going to write f of x plus h means very simple. What can you write? Tan of x plus h, that's all. For example, your question is f of x equal to sin x plus cos x is there, for example. So you are going to write f of x plus h is what? Sin of x plus h plus cos of x plus h. How many x terms are there? Wherever x is there, replace x plus h. That's all. For example, f of x equal to, you have the situation x cos x. So f of x plus h equal to, can you tell? Wherever x is there, replace x plus h. X plus h, cos of x plus h. For example, f of x equal to, you have something like that x square. So f of x plus h is equals to, what you are going to write? X plus h to the whole square. Understanding? So now your question is sin x. So that's what, in place of x I replaced as x plus h, sin of x plus h. Understanding? Now what to do? Your question. This is equals to limit h tends to 0. F of x plus h means sin of x plus h minus f of x. is sin x whole by h. That's all. Sin of wherever x plus h is substituted, wherever f of x is there, that value substituted, whole by h. So this is equals to limit h tends to 0. Sin x plus h minus sin x, it is of the form sin c minus sin d formula. Which formula? Sin c minus sin d. What is the formula for sin c minus sin d? 2 cos c plus d by 2 into sin c minus d by 2. Clear? Sin c minus sin d means the formula is 2 cos c plus d by 2 sin c minus d by 2. Now if you apply the formula where c is x plus h, d is just x. So then you are going to apply 2 cos c x plus h plus d x whole by 2 into sin, according to this, c minus d x plus h minus x by 2 whole by h, plus x minus x get cancelled. So this is equals to, so now constant 2 is there, you can able to take it outside. Limit h tends to 0, cos of x plus x 2x plus h by 2 into sin h by 2 whole by h. Now in the limits, in the previous session, in the part 1, limits and derivatives part 1, I discussed few applications, few properties. What are the properties? If you have a limit is containing more than one functions, you can able to split into individual limits, isn't it? Now I want to separate the limits 2 into limit h tends to 0 cos of 2x plus h by 2 into limit h tends to 0, limit how many number of functions are there, those many limits you can able to split. That is the property. If you are not able to understand, just look at the previous part, then you will understand easily. Sin of h by 2. Okay, now h in the denominator and which is multiplication. It is in multiplication. That's what h you can able to write either here or else here. Where it is necessary, where sin x component is there, there h is necessary. Why? Because I am trying to apply the formula limit x tends to 0, sin x by x is equals to 1. Understanding? Now what to do? This can be written as sin h by 2 is there, but only h is there here. So what can I do? So I need extra by 2 here. So operate with multiply by 2. So multiply and divide by 2. Then I convert it into formula. So according to that, this part I can able to write as 1 into, so what we can able to write 2 into, so h tends to 0. Now in place of h substitute 0, cos of 2x plus 0 by 2 into this box part becomes 1 into 2 in the denominator, that's what 1 by 2. 2 and 2 get cancelled, this is nothing but cos of 2x, 2 get cancelled and cos x. So d by dx of sin x, the derivative of sin x, you are getting cos x. This is what I discussed, right? The formula d by dx of sin x is equals to cos x I discussed, right? So by using first principle, we derived this part as cos x. I hope everyone are clear. Okay, so can I repeat once? In place of x plus h, afterwards formula introduction, f of x plus h, f of x value substitution. Now here it is of the form sin c minus sin d, 2 cos c plus d by 2 sin c minus d by 2. After cancellation, the remaining part written. Then how many functions are there? Those many limits you can able to split. So that's what I split it into 2 functions, 2 limits. So afterwards, this is what the remaining part I converted into limit x tends to sin x by x. So this part is become 1 and 1 by 2 is remaining, 2 to get cancelled. You are getting the answer as cos x. I hope you understood. Now we are going to derive the second proof, which is derivative of cos x. What is the derivative of cos x? As I discussed, minus sin x. Now you are going to prove this one. Derivative of cos x equal to minus sin x. Please copy. Coming to next. Cos x I'm going to prove now. f of x is equals to cos x. So what is the question? The derivative of f of x equal to cos x by using first principle. Okay, so this is one of the expected question from my end. F of x equal to cos x proof. So look at carefully. So cos x, and this is nothing but cos of x plus h. Almost sin x, cos x methods are same only, same format. So we know that limit f dash of x formula introduction, x to limit h tends to 0. F of x plus h is cos of x plus h, minus f of x is cos x whole by h. This is equals to limit h tends to 0. So what is the formula for, it is of the form what? Cos c minus cos d. What is the formula for cos c minus cos d? Cos c minus cos d is equals to, can you say, minus 2 sin c plus d by 2, sin c minus d by 2. This is the formula for cos c minus cos d. Now if you apply this formula, minus 2 sin c plus d by 2, x plus h plus x by 2, sin x plus h minus x by 2 whole by h. X and x get cancelled. Now what's next? In the previous question type, minus 2 outside, limit h tends to 0, sin of x plus x 2x plus h by 2 into sin h by 2 whole by h. This is equals to minus 2 out, limit h tends to 0, sin of, so same logic, two different functions are there, means you can able to split it into two different limits. I am going to split limit h tends 0. You also do along with me please, whole by, so now h is requirement is here. Why? Because I need to convert into formula here. So now here also the same logic, by 2 and into 2. So this part will become 1, 1 into 1 by 2, 1 by 2 rest. So now h value is substitute here. So minus 2 into, if you substitute it, h as 0, you are going to get sin of 2x plus 0 by 2 into 1 into 1 by 2. I hope you understood. This part is nothing but 1. 1 into 1 by 2. Let us move to here. Minus 2 into sin. 2 to get cancel x into 1 by 2. 2 get cancelled. You are getting minus sin x is your answer. This is the very important for 3 marks. Clear? I think so. Now let's move to tan x. F of x equal to tan x. The third question is f of x is equals to tan x. So f of x equal to tan x means this is tan x, this is tan of x plus h. So f dash of x equal to limit h tends to 0, tan of x plus h minus tan x whole by h, limit h tends to 0. Tan, now tan c minus tan d, there is no direct formula, yes or no? Sin c minus sin d you have, sin c plus sin d you have, cos c minus cos d you have, cos c plus cos d you have, but tan c minus tan d formula is not there. So whenever that formula is not there, you convert it into tan can be written as sin by cos format. So you can able to write sin x plus h by cos x plus h minus tan x can be written as sin x by cos x whole by h. This is equals to limit h tends to 0. Let us go for LCM. These two, cos of x plus h into cos x. Clear? Now, if you take LCM, you are getting cos x will multiply here. Sin x plus h into cos x minus cos x plus h into sin x. H by 1 is remaining. H by 1 can be written as reciprocal, it is 1 by h. This can be written as limit h tends to 0. If you see very carefully, the formula will be just sin A cos B minus cos A sin B. So these two are same and these two are same, and the formula is sin A cos B minus cos A sin B. What is the formula? Sin A cos B minus cos A sin B. The formula will become sin of A minus B. Sin A cos B minus cos A sin B is sin of A minus B. So this can be written as sin of A minus B. What is A? X plus H minus what is B? X whole by cos X plus H into cos X into 1 by H. X and X get cancelled. Then what you are going to write now? Continuation. Limit H tends to 0. Sin H remaining. Sin H remaining. Now this is the product rate. So denominator is product rate. H you can able to write. This part also you can able to keep it there over. Why? Because sin H is the means denominator. Let us write down this H. So that's what sin H by H, and this function I want to split with another limit. So this is equals to limit H tends to 0, 1 by cos X plus H into cos X. I hope you understood. In the limit formula you can able to split into two limits. So that's what limit of this thing into limit of that thing. So this can be written as this part is nothing but 1 into, so according to formula again, the property limit H tends 0 apply for the numerator. So limit H tends 0 constant is constant whole by limit H tends to 0 apply for the denominator. You can able to write limit H tends to 0 cos of X plus H into cos X. So this can be written as 1 into 1 by, now H value substitute in place of X, cos of in place of H, cos of H, cos of X plus 0 cos X. Already cos X is there. So 1 by cos X into cos X, cos square X. 1 by cos square X is nothing but secant square X. So d by dx of tan X, already I gave the formula. D by dx of tan X is secant square X. This is the formula. So this is the formula which is the most important. Okay, so remaining cot X, cosecant, secant X, the same model only, but it is not there in first PUC syllabus. So in the first PUC syllabus, only first principles are there. If you want to interested to do the continuation, you do in the same way. Cot X is also can be written in this format, cot by sin format. Okay, then you take LCM and simplify, you will be getting same as cosecant and secant also. I'll move to the next concept. So first principle is got over. Okay, next model. Next, this kind of questions are important. If f of x is equals to sin x into cos x, then find f dash of x. Important question. So they can ask in two ways, f of x equal to sin x cos x, or else y is equals to sin x cos x. If they are given y, you need to write the derivative is dy by dx. That is the derivative. If they are given f of x, the derivative is f dash of x. These are the notations you will have to know. So y derivative dy by dx. F of x derivative f dash of x. You have to know. So now f of x equal to sin x into cos x given. So that's what. Let us take the question f of x equal to sin x into cos x. So this is not by using first principle. This is what? Direct differentiation. If it is a first principle, they will mention very clearly in the question, do by using first principle. Unless until you are going to do your regular method. So f of x equal to sin x means sin x into cos x means you are going to apply differentiate with respect to x. If you apply differentiate with respect to x, differentiate means you are applying both sides d by dx. That is the meaning. Differentiation applying means d by dx applying both sides. D by dx of f of x equal to d by dx of sin x into cos x. I told you very clearly the derivative of f of x is nothing but what you are going to get f dash of x. If it is f of x, the derivative of f of x is f dash of x. Now what to do for this one? D by dx of sin x into cos x, two functions. Whenever it is two functions, you are going to apply the formula d by dx of uv. U is a function and v is also a function. So what to do? First u into first function copy as this and the derivative of second function plus second function copy as this and the derivative of first function. That's all. So you are going to write sin x into first function is sin x into d by dx of second function. What is that? Cos x plus cos x into what is the first function? D by dx of sin x. Finished. Sin x into derivative of second function plus cos x into derivative of first function. Then this can be written as sin x into what is the derivative of cos x? Minus sin x plus cos x into what is the derivative of sin x? Cos x. Clear? So sin x into sin x, sin square x along with minus cos x into cos x, cos square x. So what is this meaning? Cos square x minus sin square x. The formula is cos 2x. That's all the answer, isn't it? So whether you know very well that how to apply UV formula or not, they are going to cross check whenever they are going to ask this kind of questions. You need to solve by this way. Did you clear? So similarly, one more question they'll ask: if y is equals to sin square x, find dy by dx, like this. This is also same format. So there are two methods to solve. So one is chain rule, one more is direct method. Actually chain rule is not there in your syllabus. That's what I'm going to discuss by using this method only. Chain rule will be there in the second year. Okay. So y is equals to, you are going to write sin square x given, right? Just you mention sin x into sin x. That's all. Differentiate with respect to x. So d by dx of y is equals to d by dx of sin x into sin x. Isn't it? Now apply this formula. D by dx of uv is equals to u dv by dx plus v du by dx. So d by dx of y means dy by dx is equals to, according to this formula, u means sin x into derivative of v, d by dx of sin x plus v is also sin x into d by dx of sin x. Then this can be written as sin x into sin x derivative is cos x plus sin x into again sin x derivative cos x. Sin x cos x plus sin x cos x gives 2 sin x into cos x. 2 sin x cos x can be written as sin 2x. These two questions are very important for your subject 2. Any one of the question is expected. That's what, let us learn both the questions. Isn't it? This is sin x cos x and one more is sin square x. Few more questions. Next, they are going to give whether you know very well u by v formula or not. That's what they are going to ask this kind of questions. F of x is equals to, if f of x is equals to x minus a by x minus b, find f dash of x. Isn't it? So f of x is equals to what? X minus a by x plus b, x minus b. So differentiate with respect to x. So d by dx of f of x is equals to d by dx of x minus a by x minus b. Isn't it? This is nothing but f dash of x. So what you are going to apply here? The format is u by v, d by dx of u by v. What is the formula? V into derivative of u minus u into derivative of v whole by v square. That's all. Shall I apply now? U by v. So start with the denominator. Okay. What is the denominator? X minus b into derivative of numerator minus numerator into derivative of denominator whole by denominator whole square, x minus b whole square. Clear? So x minus a into, now d by dx of x minus a can be written as, what shall I do? D by dx of u minus v formula. What is that? du by dx minus dv by dx. So now d by dx of x minus a is there. You can able to write d by dx of x minus d by dx of constant. So what is the derivative of x? 1. What is the derivative of constant? 0. 1 minus 0 is equals to 1. So this is 1 minus, no derivative here. Let us copy as it is into same logic, d by dx of x 1 minus d by dx of constant 0 whole by x minus b whole square. This can be written as x minus a minus x minus of minus plus a whole by x minus b to the whole square. Plus x minus x cancel. So x minus a minus x, one second, x minus b into derivative of x minus a, x minus a, this is, sorry, this is x minus b is there here. Let us write down x minus b. Now this is b here. Then x get cancelled. This is nothing but a minus b by x minus b whole square is your answer. That's all. This is x minus b, right? So write down x minus b. This is x minus a. Clear? So this is the answer. Just they are going to check whether you know u by v or not. That's all. So this is what the question. Then they are going to ask this kind of questions also. So for example, like this kind of questions. Y is equals to x power minus 3, 5 plus x power minus 3 to 5 plus 3x. Find derivative. Find dy by dx. So very simple. First of all, let us convert into normal format. Don't apply uv also. So just you are going to multiply with x power minus 3 the inside function. So 5 into x power minus 3 plus 3x into x power minus 3. Then what can I write? Y equal to x to the power of minus 3 plus 3 into base are equal, powers are added. 1 minus 3 gives minus 2. Now you apply derivative. So just normal differentiation you need to apply now. So differentiate with respect to x. You are getting dy by dx is equals to d by dx of 5x power minus 3 plus 3x power minus 2 can be written as 5 into d by dx of x power minus 3 plus 3 into d by dx of x to the power of minus 2. So 5 into, I told you very initially today, so it is of the form x to the power of n. X to the power of n formula where n is equal to how much? Minus 3. What is the formula? N into x power n minus 1. So minus 3 into x power minus 3 minus 1. So that is minus 3 minus 1 plus 3 into, what is the derivative of x power minus 2? Minus 2 into x power minus 2 minus 1. Then 5 into minus 3 minus 15, x power minus 4. 3 into minus 2 minus 6 into x power minus 3. That's all your answer. So this kind of all questions, the logic is just multiply inside, then apply normal derivative. Almost x power n derivative only will be exists. If you apply, you will be getting the answer. Clear? Can I move to next? Similar model. Otherwise, the question they are going to ask like this. So y is equals to 5 secant x plus 3 tan x minus 5. Like this kind of questions. Find dy by dx. Okay, very simple. Just apply differentiate with respect to x. dy by dx is equals to d by dx of 5 secant x plus 3 tan x minus 5. This can be written as d by dx of u plus v plus some w. You can able to split into individual derivatives. 5 secant x plus d by dx of 3 tan x minus d by dx of 5. This can be written as 5 constant, keep it outside, d by dx of secant x plus 3 constant, keep it outside, d by dx of tan x. It's a pure constant. Constant derivative is 0 according to formula. So 5 into secant x derivative, secant x into tan x given in the list of the formulas, plus 3 into tan x derivative is secant square x. If you want, you can be able to take secant x as common. Then you are getting 5 tan x plus 3 secant x is your answer. So this kind of questions also very easy. And the derivatives, if you want to do very well, the formation is nothing but formula. The formula is the most important. If you know the formula, you can able to apply immediately. Okay, and last and final model, which is the most important, I will discuss that one afterwards. I'll conclude the class. Okay, this is the one of the expected question and important question. Look at once. In your textbook, question number 5. For the function, question number 5 in your textbook, for the function f of x is equals to x power 100 by 100 plus x power 99 by 99 plus so on plus x square by 2 plus x plus 1. Prove that f dash of 1 is equals to 100 f dash of 0. Prove that f dash of 1 is equals to 100 times of f dash of 0. This is the question. Okay, let us consider the given question. F of x given, that is x power 100 by 100 plus x power 99 by 99 plus so on plus x square by 2 plus x plus 1. Okay, so in your question, if you observe carefully, f dash of 1 is equals to 100 f dash of 0 they are asking. So first of all, you have to find out f dash of x. Once if you are finding f dash of x, you are going to replace x equal to 1 and x equal to 0, x equal to 1 and x equal to 0. That's all. So let us go with f dash of x first. F dash of x, if you want to do, means just you need to apply differentiate with respect to x. Differentiation means applying both the sides d by dx. D by dx of f of x is equals to d by dx of x power 100 by 100 plus total x power 99 by 99 plus so on plus x square by 2 plus x plus 1. Now d by dx of f of x is what? F dash of x is equals to, now d by dx of multiple functions are there. You can able to do individual derivatives. D by dx of x power 100 by 100 plus d by dx of x power 99 by 99 plus so on plus d by dx of x square by 2 plus d by dx of x plus d by dx of 1. Clear? Are you clear? This is equals to, it is of the form, look at, so generally what you are going to apply, d by dx of x power 100 by 100. What to do? It is look like u by v. It is look like u by v form, but don't apply u by v here. So when we are going to apply u by v means d by dx of u by v you should apply whenever u and v both are functions. Both are functions means apply. But any one of the result is constant means don't apply. Just to take it outside the constant. That is only your trick. So now if you observe here, x power 100 is a function, but only pure 100 is not the function. This is the constant. That's what. Let us take out from the derivative. So if you take out the derivative from the derivative that 100, it will become 1 by 100 into d by dx of x power 100. Clear? Plus here also 1 by 99 take out, d by dx of x power 99 plus so on plus 1 by 2 into d by dx of x square, and d by dx of x is equals to 1, d by dx of pure constant is 0. Isn't it? Now look at carefully, 1 by 100 into, we are trying to skip the formula as u by v, and general formation you are getting, it is of the form x power n, x power n derivative n into x power n minus 1, 100 minus 1, 99 plus 1 by 99 into, what can I write? 99 into x power 98 plus so on plus 1 by 2 into x square derivative 2x plus 1. 2 get cancelled, 99 get cancelled, 100 get cancelled. It remains x power 99 plus x power 98. Okay, plus so on plus x plus 1. If you observe how many terms are there, means so f dash of x is this one, right? Now f dash of x ready. So as for our discussion, f dash of x ready. Now you are going to replace x is equals to 1 and x is equals to 0. If you take x is equals to 1, what happened? f dash of 1 will get is equals to 1 power 99 plus 1 power 98 plus so on plus 1 plus 1. Now how many ones are there? 1 power 99 is equals to 1 only. 1 power 98 1 only. So on plus 1 plus 1. How many ones are there means look at carefully. This is x power 1 to x power 99. Total how many? 1 to 99 means 99x. 1 extra means 99 ones these are plus 1 is extra. So 99 plus 1 it is nothing but 100 ones. So f dash of 1 you are getting 100. Now let us take put x equal to 0 in the same function. Which function? Let it be called 1 0 in 1. If you take x is equals to 0 in the function, so what happened? F dash of 0 is equals to 0 power 99 0 0 power 98 0 plus so on 0 power 1 0 plus 1. So you are getting 0 plus 0 plus so on plus 0 finally plus 1. It is nothing but what? 1. Isn't it? What is RHS actually? F dash of 1 is equals to. What is F dash of 1? This is nothing but LHS. F dash of 1 how much you are getting? 100. Now let us consider RHS. What is RHS? 100 into F dash of 0, right? So 100 into F dash of 0 is equals, just now we proved 1. 100 into 100, how much? 100. Now LHS and RHS both are same. Therefore, you can able to write F dash of 1 is always equals to 100 into F dash of 0. So this is your answer. Okay, LHS and RHS both are equal. This is the one of the very expected and important question, isn't it? So this is what the derivative from first year. This is enough from first year. Okay, so this is for today's session, and I need to explain sandwich theorem. That is what limit x tends to 0, sin x by x is equals to 1. I will put separate video on that. I will do separate video on that. The proof of limit x tends to 0 sin x by x equal to 1 very soon. Okay, sir. That's all for today's class. Thank you so much. Thanks a lot.